Hey everyone! So today, we're diving into some really cool insights from Dr. Sasanazijian about a couple of Java's more, well, hidden tools, the instance-of operator and native methods. You know, these things can be incredibly powerful, but you've got to know the catches. So, let's jump right in.
You know that feeling, right? You've hit a wall in your code. You're looking at an object and you're just like, what are you exactly? Or maybe you're trying to squeeze out some performance that plain old Java just can't seem to give you. I mean, these are the kinds of headaches that can bring a project to a crawl. But don't worry, today we're going to look at some pretty clever ways to solve these exact problems.
Okay, so first up, let's talk about this identity crisis. A lot of the time, our programs are handed objects, and we have no idea where they came from. To get any work done, we have to be able to ask that object a really simple question. What type are you? And if we can't get an answer, well, our whole application can just grind to a halt.
And yeah, this is exactly where things can go, well, spectacularly wrong. Because if you guess wrong about an object's type and you try to cast it to force it into a shape it just wasn't made for, your program doesn't just fail, it crashes. Hard. And you know it's never going to happen when you're testing it right? No, it's going to happen when a real user is in the middle of doing something important. It's a total developer nightmare.
So the big question is, how do we dodge this bullet? Well, Java gives us this really elegant, simple little tool, the instanceof operator. It basically lets us ask an object right there at runtime, a direct question. Hey, are you a string or are you a customer? And you get back a straight answer, a simple no-nonsense yes or no.
And the syntax, it's about as clean as you can get. It's literally just your object, the word instance of, and then the type you're checking against. That's it. And that simplicity, that's a huge win for making your code easy to read. I mean, anybody on your team can look at that line and know exactly what you're doing. That's so important for maintaining code down the road.
Okay, so let's walk through how this actually works. Imagine you get some generic object, but you know you need to call a method that only exists on, say, the dog class. The safe way, the professional way to do this, is to use instanceof as a little guard clause first. You check, hey, is this object an instance of dog? And only if it comes back true, then you go ahead and safely cast it. It's this simple check that just gets rid of all the guesswork and stops those awful runtime crashes.
I love this analogy. Think of instance-of as asking an object for its ID card. Seriously, your type-specific code, that's like a VIP restricted area. An instance-of, that's the bouncer at the door, checking IDs. It makes sure only the right kind of objects, the ones with the right credentials, are allowed in. It's just a perfect way to think about this super important safety feature.
Okay, so instanceof is fantastic, right? It's a great tool for keeping order inside the world of our Java application. But what happens when the problem you're facing just can't be solved by Java alone? What if you need to reach down and tap into the raw power of the hardware? Or what if there's this amazing library you need to use, but oh wait, it's written in C?
This is where we have to step outside the cozy, familiar borders of the Java ecosystem. We're about to cross the language barrier. We're going to see how our Java code can actually talk to code written in totally different languages, like C or C++. And trust me, this is where things get really, really interesting and, a little bit dangerous.
The secret to making this all work is one little keyword, native. See, when you declare a method as native, you're basically making a promise to the Java compiler. You're telling it, look, I know this method looks empty, but trust me, the code for it exists, just not in any of my Java files. It's over there, in some other pre-compiled library. And the compiler just kind of shrugs and says, okay, I'll take your word for it, and lets you call that outside code.
So you might be asking, why on earth would I go through all that trouble? Well, it really boils down to two big things, speed and access. First, speed. For some really intense number-crunching tasks, native code can just blow Java out of the water. And then there's access. Think about the massive universe of existing libraries out there, decades of battle-hardened code for stuff like complex statistics or controlling hardware. The native keyword is your key to unlocking that whole treasure trove.
Now, the first time you see the syntax for a native method, it's a little weird. You declare it like any other method, but where the curly braces and all your code should be, there's just a semicolon. It just ends. And it feels totally incomplete. But that's the whole point. You're telling Java, hey, the implementation, not my problem. That's handled by some other library somewhere else. But, and this is a really big but, All of this incredible power comes with a very, very hefty price tag. Using native methods is absolutely not a decision you should make lightly. There are some serious trade-offs involved, and if you're not careful, this supposedly helpful tool can turn into a really dangerous trap.
And this really gets to the heart of the dilemma, right? On one side, you've got this incredible promise, blazing fast speed, access to any library you want. But on the other side, you've got two of the biggest red flags in all of software development, huge security risks and a complete loss of portability. So yeah, let's break down what that really means.
Okay, let's talk security first. You know how the whole point of the Java virtual machine is that it's a sandbox, a safe, contained little playground where your code can run without messing up the rest of the computer? Well, native code takes a sledgehammer to that sandbox. It just shatters it. That native code runs with the same permissions as any other app on the machine. It can read your files, open network connections, do whatever it wants. That is a massive security hole, and it's exactly why you see native methods locked down so tightly in things like applets.
All right, problem number 2. And in a lot of ways, this one cuts even deeper for us as Java developers. We all know the mantra, right? Write once, run anywhere. It's the core promise of Java. Well, native methods completely break that promise. The second you use one, your beautiful portable Java program is now shackled to a specific operating system and a specific CPU. Your Run Anywhere app now only runs here. It's a huge step backward.
So what's the final word on this? Well, the expert advice is pretty blunt about it. You should really restrict your use of native methods. For most apps, the cost you pay in portability and security is it's way too high. Think of it as a tool in a glass box that says, break in case of extreme emergency only.
Okay, let's pull all this together. We've looked at two very different tools in the Java toolkit, each designed to solve a very different kind of problem. So what are the big takeaways here? What do you really need to remember?
First off, use instanceof. Use it all the time. It's your best defense against those nasty casting errors and runtime crashes. It's just good, solid defensive coding. Second, when it comes to native methods, you have to treat them with respect. They are powerful, yes, but they're also dangerous. They're your bridge to the outside world, but it's a rickety bridge over a deep canyon. And that brings us to the last point. Never, ever forget the trade-off. When you use a native method, you are trading security and portability for power. And you always need to stop and ask yourself, is that a price I'm really willing to pay for this project?
So that leaves us with this one big question, doesn't it? Are native methods a powerful tool that you pull out for very specific, tricky problems? Or are they a dangerous liability that kind of betrays the whole spirit of what Java is all about? And there's no easy answer. It really does depend on what you're building. The most important thing is that now you understand the trade-offs so you can make a smart, informed decision. Thanks so much for tuning in.